All right, we're going to try to walk through the furthernmap tryhackme room. So I'm going to go ahead and start up my Kali box. Again, the point of this room is just to really gain some familiarization. So when we're doing this in the actual PD session, we may not actually run through the entirety of this. I'm not necessarily expecting you to be able to get through all of it in the handful of minutes that we have access to in the PD session, because we got to cover a bunch of stuff. So I'm gonna go ahead and go full screen. And I'm going to, as usual, open a terminal, see if I can get to Google. I can, so that means I have connection to the internet. Good deal. Just like the other labs that we're gonna have to connect into tryhackme, we're probably gonna have to get on the VPN. So what I'm gonna do is put a window right here, and that'll be kind of our VPN connection. I'm going to open up Firefox. I'm actually going to navigate to the tryhackme room. And it should be tryhackme.com/room furthernmap. And it's telling me I got to log in. So let me go ahead and log in real quick. And I saved my username and password because I'm just going to burn this box afterwards. Oh no, tractors. I don't have any tractors in there. Traffic lights. I do have traffic lights. And some more traffic lights. Okay, I'm not a robot. Good deal. Okay. One thing we can do is we'll click on the Access tab, and so we can sort of watch our connection come online. So yesterday or some other day or some other previous time, we actually went through the process of downloading the configuration file. Long and short of it is you come to this access page by getting to your username access or your profile picture access. You can download the file. It'll end up in your downloads folder. So if I look at the stuff, list the stuff in downloads, I see I have my download pack. That's the file that they download right here. You can see that I'm currently not connected and I don't have an internal virtual IP address. So how do I get connected again? It's sudo openvpn. Goodness gracious. The reason that wasn't working because I have to go into the directory. Downloads. Here, OpenVPN. VPN. Type my password. With any luck, I'll see this initialization sequence completed. That generally means I'm online. If I come over here and refresh, hopefully I'll hit a green check mark. I do. Okay, so I'm connected. I'm going to minimize that window for right now. And then I'm going to go back to the furthernmap room, I think. Yeah. Okay, so I'm logged in. You can see my IP address up here in the top right. Press the green button to deploy the machine. That's the very first task in this whole room. So I'm going to press that button. It says starting your machine, please wait. Because we haven't done this before, it says to access this machine, use a VPN. That's what we've already done, or use the attack box. If you pay for an account, you can use their web-based attack box. It means you don't have to install anything. You don't even have to have a Kali VM. They kind of give you one that you can access on the website. We're connected with the VPN because that's free. All right, so what's happening right now is it's booting that machine up virtually. You can see that it's going to show us the IP address so that we can potentially connect to it. At some point in the future, we have 2 hours worth of time before it automatically like self-destructs. But if we need an additional hour, we can press the add 1 hour button. Or if we're done with our exercise early, we can go ahead and terminate. So at this point, all we have to do is press the green button. There's no thing we have to do, so we can just hit the completed, and then that task will go green. You can collapse it and open the next one. So here it looks like they're going to give you a little bit of an introduction. So as in the previous diagram, yada, yada, the computer has a total of 65,535 available ports. Only some of them are registered as standard ports. Yada, yada. All right, so, I mean, you can jump down to the end here. What is the networking constructs used to direct traffic to the right application on a server? I don't know. Oh, gosh. Okay, so they probably, this is like your test questions. They're asking you a bunch of things here. I'm going to guess ports. That was correct. What networking constructs are used to direct traffic? Where did I find that? Ports. Making it even, if we don't know what port surfing is, anyway, if you read through that, I'm sure that they probably explained something of that to you. How many of these things are available on any network enabled computer? So you could have got that from the context of just reading this sentence and reading the next question might have given you the context. So there are 65,535. And so this one's labeled as research, like maybe they didn't give you the answer inside of this. So I'm going to open a new window for Firefox. So I have a window to sort of Google on and then look at my question. This isn't cheating. This is what this is what you're doing. You're researching, you're learning things. When you go into the workforce, this is how people expect you to be able to conduct yourself. So let's see, research. How many of these are considered well-known? These are the standard numbers mentioned in the task. Okay, so I think they said many of these are registered as standard ports. So from our intro to research room, we found some interesting stuff out. I'm going to go to Google. How many standard port numbers? Port numbers 0 to 1023 are common and are called well-known ports. So 0 to 1023 is 1024 total because 0 is a perfectly valid number. What's our hint say first? How many well-known are there? Substituting your answer for question 1. Oh, so they even tell you what to Google. All right, cool deal. So there should be 1024. If we look up, looks like we are done with that section. So we can collapse it. All right, so Nmap switches. Like most pen testing tools, Nmap is run from the terminal. Okay, so let's open up a new terminal, not the one that we have connected to our VPN. I'm going to keep that one minimized. And I'm going to open a new one. I'm going to go up to the top left there. I'll keep this one right there as well, I guess. Try to zoom in. Okay. It says there are versions for both Windows and Linux. Nmap's already on the Calibot. Okay, so you can go to the terminal and just type Nmap. We should have already done this. If you haven't seen this, this is what the terminal looks like. So Nmap 791 version 7.91, followed by some switches. All of these things that you're seeing here, we'll call them flags or switches, arguments, parameters, things like that. Generally, it means ways to affect like how the program is going to run. So we can give it the flag TAC H, TAC meaning dash, or hyphen. So we can also type map-h, get basically the same thing. If we wanted a more in-depth explanation of what a lot of those things are, we can look at the man page, man Nmap. That'll take us into the Linux man pages, and we should have looked at this already, but you get a lot more detail about what an example scan even looks like, what it returns to you. You can hit Q to exit out of that. So in the help menu, what is the first switch listed on the help menu for a SIN scan? So how do I look at, if I scroll up a little bit, I can see I see scan techniques. And I see TCP SYN /connect/act/windows/mymon scans. Okay. What's another way to find this information? I'm going to go into InMap. I'm going to do the slash to search. I'm going to say SYN scan, see if anything shows up. Slash enter. Okay, so TCP SYN scan. This is one way to find it. We saw it in the other menu. It was actually the TAC SS. I'm going to guess that that's it. And again, Linux cares about case. So TAC little s is not the same as TAC little s big S. So I'm going to hit submit. That looks like it's the correct answer. So which would you use for a UDP scan? I'm going to scroll around. Those are all right there. TAC SU, big U for UDP scans. That fits the answer format. Those three characters. I'm gonna try the S, capital U. Seems like that worked. All right, if you wanted to detect which operating system target is running on, which flag would you use? Operating system. How do I find that? All right, this time I'm going to use Google. InMap operating system switch. What does it say? If you wanted to detect the operating system is running on, let's click this one and see. This takes us to the InMap website. TAC-O enables OS detection. That looks like the font isn't great. That could almost pass for a 0, except for this font is a monospace font and it would have the little pip in the middle of it. So it's a big O. I'm pretty confident. Operating systems are big pieces of software, so they need big O's if you want to detect them. Maybe that'll help you. 0. All right, so what's it say? InMap provides a switch to detect the version of services running on the target. What is this switch? Let's see. Oh, this is bugging me, and I'm going to take a minute just to figure it out. If you click around, like you'll notice that I have more than one terminal open, but they've sort of grouped them into a single button. I hate this. This is by default in Kali. You can disable that by right-clicking somewhere along this. You'll get the opportunity to see properties. Okay. That wasn't it. That's not the right one. You don't want the one that says separator. Maybe it's panel preferences. And then somewhere in here, appearance. No, that's not it. Items. Somewhere in here, it's Windows buttons. Properties. Never. Okay, that was it. Man, I don't even remember how I got there. I wish there was a way I could like programmatically resolve this. Maybe there is, maybe there isn't. I don't know. Anyway, I went to panel properties, Windows buttons. I had to scroll down to find Windows buttons. Click the little the hamburger like icon, and then window grouping never. Close, close. Now I can know to just kind of keep this one away. Just not look at that one anymore. I'm going to minimize it, and I know that the one I'm working on is always going to be, not that one. So, anyway, what was our question? What were we looking at? That was a quick aside. InMap provides a switch to detect services. Okay. / let's do that. I'm going to get out of the man page. I'm going to use the TAC-H. And I'm going to grep. I'm going to cheat. I'm going to use grep. Grep services. That didn't work. Capital S services. That didn't work. Man, that's what I get for trying to cheat. Maybe it goes to standard. I would still see it if it went to standard out. What's it say? Is there services anywhere in here? I know the answer, but it's SV. Right there. See why that didn't work out is because I did plural. Let's do this real quick. Okay, so nmap-h show only the lines that contain service. SV, probe open ports to determine service version info. So if you want to scan for versions, it's a TAC S scan for capital V versions. SV, submit. How many default output, but the default output provided by nmap often does not provide enough information for pen tester. How would you increase the verbosity? Verbosity is like how much additional extra info is provided to you. Let's see. I would imagine there's a convention in like a lot of Linux programs that if you use TAC V, that's verbosity, like a lowercase v is I want to be verbose. And sometimes if you add multiple V's, you can sort of increase the verbosity. So you want to see a little bit of extra information, but not all the information that's available. You could put maybe 2 V's. If you wanted every bit, you could maybe put 3 V's. So maybe there's like a scale that you could go through. It looks like this big V is to print the version number. I'm going to do that same trick. Grep for verbose, dash V, use VV for greater effect. Dash V, submit. Whoop, whoop, we're correct. Now, all the while, this machine has been starting up and it's doing its thing. It's just kind of sitting there idly at this IP address. So we're going to hopefully get to scan it here in a little bit. So verbosity level 1 is good, but verbosity level 2 is better. Dash VV. It's highly advisable to always use at least this option. Okay. I haven't used it that way. I don't normally turn the verbosity on, but we'll try it in these scans and we'll see what it does for us. Okay, so we should always have save the output of our scans. And this is absolutely, they should have added this number, that note to this point. So we should always save the output of our scans, meaning we want to, rather than have to run the program over and over again, we want to save it some way that we can reference it later. This will help us sort of maintain a low profile. We're not having to constantly scan the network and then scan it again and then scan it again because we forgot something or we accidentally lost our terminal or closed it or our computer crashed or something like that. So which would you use to save the nmap results in 3 major formats? Let's look at the help options, and then output is kind of what we're thinking of there. Like, how do we save out the files? Let's see. 3 major formats at once. -OA for all the major formats. We want to put out all the major formats. We want to save, we want to write out all the files, or all the file types anyway. Those 3 file types that you're going to get are the normal nmap text scan, the XML scan, and then the greppable format. They're all going to contain the same type of information, but it'll be presented differently. The normal scan will be just like what you would see on the screen. The XML scan is, or the results rather, in XML format will be useful for importing and exporting into other programs. Hopefully we'll look at that later for how to sort of use nmap as part of a pipeline of tools, and then capturing the output and then using its output for some other purpose. Greppable format is useful for answering quick questions on the command line. It's if you wanted to find all the information basically lives on one line. So formatting is completely lost, like in the normal output, but it has its benefits. Like if you were looking for all the hosts that had a certain port open, it'll be a lot easier to find that information in the greppable format file than it would be in the normal format file. And if you weren't writing a tool that was XML aware. So what does it say? It said tech O, capital A, submit. Which switch would you use to save the nmap results in normal format? ON? Yeah, tech ON, submit, correct. A very useful output format. How would you save in the greppable format? Oh, tech OG. Sometimes the results we're getting just aren't enough. What if we care how loud we are? We can enable aggressive mode. This is shorthand switch, which activates service detection, operating system detection, a trace route, and common script scanning. I think I haven't heard it called aggressive mode, but I like that. I like that maybe even more than what it was. Let's scroll around. Let's say sometimes the results we're getting for the shorthand switch to activate service detection, operating system detection, trace route. So let's look at our scan types. Well, under miscellaneous, I see it right here. Enable operating system detection, version detection, script scanning, and a trace route. Shorthand switch to activate TAC OA. I always said about the TAC A switch, it's a big job, so you need to use a big A. If you wanted to get your services, your operating system, a trace route, I mean, I don't really care about the trace route a whole lot, but the common script scanning, that's a big job. You want all the information. It's a big job. Use a big A. All right. So, but I like aggressive. TAC big A aggressive. It's a lot of information. So you use a big A for aggressive. I like it. Good. Nmap offers 5 levels of timing templates. These are simply used to increase the speed your scans run at. Be careful though, higher speeds are noisier and can incur errors. How would you set the timing template to level 5? Okay. I'm gonna do this thing, Brett. Timing. I just searched again. I ran the nmap-h command, but I said I want to filter out all the lines. I only want to see lines that contain the string, the word timing, lowercase t. Okay, so it looks like capital T, and then these angle brackets just are like basically like some value, right? So it's either going to be 0 up to 5. So it looks like TAC big T 5. So I would say that if you're authorized to run a scan and you're not worried about attribution, like people know that you're supposed to be scanning, and you're doing it maybe in a less than mission critical like environment, T4, T5 is totally fine. People will say, oh, but you'll crash the network, you'll break stuff. If that is the thing that's going to make your network break, you had other problems that need to be addressed before, somebody coming in with completely off the shelf tools and running a completely normal scan like that. You had other issues going on. So, but that being said, don't do it on a hospital network, right? Don't do it on the surgery, operating bay or anything like that. So just in case, or at least ask permission to. So we can also choose which ports to scan. How would you tell Nmap to scan only port 80? Okay, so let's see. How do we scroll? Let me go back to the man page. Man Nmap. This is okay. Yeah, you can search through it this way. Honestly, oh, wait a minute. Did I see it? Didn't. There's lots of good stuff in here, but sometimes Google already knows the answer because you're not the only person to have asked it, right? So how do we tell Nmap that we only want this thing? In fact, I don't even have to leave this thing. I just hit a new tab. Check if port 80 and 8080 is open. I don't even have to leave the page. I bet I will find the answer without going into a link. Right there, tech P port ranges. So close that. It says for port 80, tech P, 80, lowercase p, and then the port. Now, what's interesting about that is you can do comma separated values. So if I wanted to scan two different ports, port 80, and they were saying 8080, these are two very common web server ports. We could also do 443. That's a web server port that is using TLS or SSL. That's another way that you could scan for those three ports. That's not the question they're asking, though. It's how do you scan only for port 80? How would you tell Nmap to scan all ports 1000 to 1500? So let's see. Let's look for in here tech P. Okay, port range. Let's see. Only scan the specified ports, e.g. separated by a hyphen, e.g. 1 through 1023. So it's the answer's in there. It looks like it's also right here. So I'll say tech P 1234 hyphen 1500. Submit. Very useful option, should not be ignored. How would you tell Nmap to scan all the ports? This one's a very cool shorthand. You can specify TAC P TAT to scan all ports from 1 to 65,535. 65535. Oh, that's wrong. That's not the question they are asking. How would you scan all the ports? TAC P TAC. Submit. All right. How would you activate a script from Nmap scripting library? Lots more on this later. Okay, so I'm searching through within the man page for script. SC or script. What is it asking for? How would you activate a script from the Nmap scripting engine? So it looks like tac script is what they're asking for, not tac SC, which scans the default scripts. So let's see, tac script, submit. Okay, so tac script, and I have to activate some specific category. It says script category. I think I can do script equal VOLN. What's the hint say? There are two variants of this switch, one with a space and one with equal signs. Look at the asterisk in the answer field to see which one it is. So they're saying count the asterisks, again, sort of giving you that context clue. Script, I didn't see a space, so I know I need to use this version. Boom, submit. Looks like I got the right answer. Okay. And it is 0247. Let's see, let's move on to the next category, I guess. It should collapse that previous task and show me this one. So it says when scanning with internet, there are three basic scan types. There's the TCP connect, the SYN half open, and UDP scans. Additionally, there's 7 less common scans. There's a null scan, the FIN scan, and the XMS scan. So honestly, I don't really use those all that often, except to tell people that they exist. So let's see, what is it doing? These will be kind of useful for more like identifying a device that you know its behavior. You know that perhaps some type of firewall or some network device reacts weirdly when you send it malformed TCP packets. That's what the XMS scan is. It stands for like you're lit up like a Christmas tree. Xmas, right? So all the flags are on, meaning and again, we may have gone over in just enough networking, what bits are represented. So you have your SYN, your SYNAC, your ACK, your FIN, your TCP reset. If you set, and they all they occupy a space within the header fields. And if they're all turned on, imagine all the light switches being on. Again, your house is lit up like a Christmas tree. It might cause that device that you're sending that packet to react in a way that maybe the developers didn't anticipate, or in some way that you can uniquely identify some characteristics about that type of device. So this is a plain Jane normal connection, the TCP connection. You don't need root privileges to even do this one. You do need root privileges to do the SYN half open scan, because you're lying about how, like, what stage you are in the communication. You are making the connection, you're allowing them to respond, but you're not responding to their response. You're basically hanging up the phone. And UDP scans are not connection oriented anyway, so you shouldn't need administrator privileges to be able to send those. Okay, so good deal. We didn't have to do that. So minimize that one. So let's see here. Now we are on to TCP connect scans. Man, this will probably be some great information as a recap. I feel like I shouldn't be reading all of this to you. I feel like I should probably just try to help you answer these questions real quick and figure out how to go about solving them. So it asked, which RFC defines the appropriate behavior? I saw the word, the letter RFC show up right there. So I'm just gonna guess, honestly. 793. I imagine that's right. For example, why? So it defines the appropriate behavior for the TCP protocol. Connection does not exist, X closed, then a reset is sent in response to any incoming segment except another reset. Okay, so this is defining the that behavior I was kind of talking about just a few moments ago with regards to like potentially sending sort of a signal out of order or out of sequence. That is to say, like I'm saying goodbye as the first like part of our conversation before I've even said hello. You might be taken aback by that. And RFC 793 explains some of that and the other ways in which it should work. If a port is closed, which flag should the server send back to indicate this? Well, we just read that. If the connection does not exist, reset is sent. And that reset is abbreviated to, I think, RST. RST. Deal? Hey, that's that section. Great. So looking at this, as with TCP scans, SYN scans are used to scan the range. However, the scan type work differently. SYN scan is for a half open scan or stealth scan. Sends back after receiving the SYNAC. This prevents the server from repeatedly trying to make the request. In other words, port looks like this. Great. Okay, so there are two other names for SYN scan. What are they? The first one was half open, and then I think it was comma, half open, comma, stealth. I saw that right here. I'm trusting that they're gonna go, oh, lowercase for me. Uh-oh, it's wrong. Half hyphen open, hyphen open. Yeah, that was it. I needed a hyphen in there, I guess. Can InMap use SYN scan without sudo permissions? Trick question. If you're root, you don't need sudo permissions. Yeah, the core of the question is, do you need elevated privileges to run a SYN scan? And yes, you should. Probably is a big why. I probably should have done that. What? Am I wrong? I might be wrong, y'all. Happens. Let's read. Let's learn together. I see they have a 1 right here. Can you use a SYN scan? Oh, I read the question wrong. Dang it. All right, it says, can Nmap use SYN scan without sudo permission? So I guess that question is no. All right. Well, welcome to computers, y'all. That had nothing to do with computer. I just didn't read the question. Sorry. Can't win them all. All right, let's see. Unlike TCP, UDP connections are stateless. This means if they're initiating yada yada, say the switch for UDP scan is TAC SU. When a packet is sent to an open UDP port, there should be no response. When this happens, in order for being open filtered. Oh, okay. So this is good. You want to see this this little bit here. So when we look at the actual output of an Nmap scan, I think it'll show up like right here. The state of a port, unless we explicitly ask it to, it generally doesn't show us closed ports. We really care more about open ports. But there are situations where you can't confirm that something's open, but it didn't overtly express that it was closed. So that's when you'll see something kind of like this filtered or TCP wrapped or something like that, where there's behavior that is not indicative of being freely open to communicate, but also not completely closed off to communication, or failing to respond to your communications. So if a TCP report doesn't respond to an Nmap scan, what will it be marked as? I'm sorry, if a UDP port doesn't respond to an Nmap scan, what will it be marked as? If it doesn't respond, let's see here. When this happens, it refers to as open hyphen unfiltered. So it looks like, can I just, guess I can open filtered. Nice. All right, cool. When a UDP port is closed by convention, the target should send back an ICMP port unreachable. Is that what it is? The closed port, ICMP, packet containing message that the port is unreachable, identifies closed ports. Marks closed, it's moved on. Which protocol? ICMP. ICMP. Internet Control Message Protocol. Yes. All right. So now we're done with that section. Cool deal. Oh, okay. We're going to get some more exposition on this. Null, fin, and Xmas are less commonly used. I'm not going to go into a lot of depth. All three are interlinked. Due to be even stealthier than the SYN scan, beginning with null scans. The name suggests is sent with no flags. Okay, so here's a great example of like using Wireshark to sort of witness how this tool works. These are all the flags. We have SYN, we have ACK, you have SYN ACK. If both of those bits are on, then you have a SYN ACK packet. Fin scans and null being nothing, right? None of them are set. The fin scan, we can see that fin is set. Xmas scan, we should see everything, or not everything, but many things are set. Lit up like a Christmas tree is what I've always heard. So, it's referred to as an XM scan as the flags it sets, push, urge, fin, give it the appearance of a blinking Christmas tree when viewed as a packet capture in Wireshark. Interesting. Okay, well, maybe we can explore that. Which of the three scan types use the urge flag? Not the fin scan, not the null scan, but the Xmas. Right? Null has nothing. Fin is only fin. Why are those you generally use? What's the answer they're looking for? The answer they're looking for stealthier. Yeah. Let's see. Does it say? So why are null, fin, Xmas generally used? Firewall evasion. Oh, okay, yeah. Firewall. I was looking for words that match that profile. I think that'll work. That was it. All right, cool. So it says firewall evasion. Many firewalls are configured to drop incoming TCP packets to blocked ports, which have the SYN flag, thus blocking new connection initiation requests. By sending requests which do not contain the SYN flag, we effectively bypass this kind of firewall. While this is good in theory, most modern IDS solutions are savvy to these scan types, so don't rely on them to be 100% effective when dealing with modern systems. So, okay, if you find yourself in a place that doesn't have modern systems, really legacy industrial environments, maybe consider that. Okay, which common OS may respond to null with a reset for every port? Okay, so they're talking, I see reset right here. Microsoft Windows and a lot of Cisco devices are known to respond to a reset to any malformed TCP packet, regardless of whether the port is actually open or not. This results in all ports showing up being closed. Interesting. Microsoft Windows. Sweet, that was the right answer. Cool. All right, let's press on. We are at 3. Okay, so what is this here? Scan types, ICMP network scanning. First connection to an target network on a black box assignment, our objective is to first obtain a map of network infrastructure, or in other words, we want to see which IP addresses contain active hosts and which do not. Ping sweep, okay, yeah, absolutely. Get a lay of the land. Some of those scans, they're going to be in depth, and if you know that you're knocking on a door when no one's home, that's, I mean, there's, I guess, in certain analogy that holds true. You don't necessarily want to waste your time doing that. So ping sweep. So to perform ping sweep, we use the TAC SN in conjunction with IP ranges, which can be specified either with a hyphen or CIDR notation. So if we wanted to scan this network, the entirety of it, we could do 192.168.0.1-254. Sweet. Okay. The tag SN tells Nmap not to scan any ports, forcibly relying on ICMP or ARP requests. Okay, that's interesting. If you're on the same network segment, it will use ARP if run with sudo or directly as a root user to identify targets. Nice. That one's interesting. That one's interesting. It won't be of much use to us like hacking over the internet, but if you're in a local network environment, there's something to be gained from that. Good insight. So in addition to ICMP echo requests, the TAC SN will also cause Nmap to send TCP SYN packet to port 443 of the target. Let me read that again. It says, in addition to ICMP echo requests, the SN switch will also cause Nmap to send TCP SYN packets to port 443 of the target, as well as a TCP ACK or SYN, if not run as root, to port 80 of the target. Okay, so it'll probe it to see, is this a web server, basically. 443 and 80 are common web server ports, the default kind of like web server ports. So when you perform a ping sweep on the 172.16 network mask of that using Nmap. Okay, let's build out our command in Visual Studio Code. We should have installed that yesterday or some other day, whenever you guys watch this. I'm going to open that up. So it should look like it's asking us, how would you perform a ping sweep? So we're supposed to type out the entire command. I'm going to do it over here so that I can watch my spacing of everything. So the command name is Nmap. It looks like I'm going to do a ping sweep. So TAC SN. So I don't want to do any of the other fancy ping, or I'm sorry, mapping techniques or scanning techniques. It's asking me for, it looks like the IP address in CIDR notation. So 172.16, and CIDR stands for like classless interdomain routing. It's basically, rather than having to type subnet masks like this all the time, you can say, I'm sort of collapsing all of that information. I'm saying, I want, in this instance, I want the 16 bits, like each one of these octets is representing 8 bits. And the first ones are what are identifying the network itself, and the last 16 bits are what's identifying the hosts on a network. And this is saying these 16 bits, we're taking 16 bits and applying them to the first 16 bits that you're going to encounter. Those are the things. So that's unfortunate. In a class C network, which you might have seen, like 192.168.1.1 or 0 through 255, right? That's an old class, or not old, and it's common, class C network, net mask 255.255.255.0. That CIDR address is /24, right? So I'll say 1 through, well, no, because 0 is also a perfectly valid IP address in that range as well. So 0.255. So that's, that's a /24. We're saying 3 times groups of 8 as 24. Though these 3 groupings of numbers represent the network. There's one, a single network, and then there are 256 discrete IP addresses behind that network. If I were to change that to 23, then I basically cut this number in half. So it would be, what, 127, if I'm not mistaken? Or did I go the wrong way? Oh, I went the wrong way, actually. Anyway, net masking, subnetting in public. The answer to this question is 16. Let's get out of here before we get into trouble. Submit. Hint. Oh, the CIDR notation for Class B network with the default net mask is /16. Cool. All right. What else? Man, video's lasting a while. Let's see. Oh, we're done with that one. So let's move on to the next one where it says script. The Nmap scripting engine is incredibly powerful in addition to Nmap. Extending its functionality is quite considerable. NSC scripts are written in Lua programming language and can be used to do a variety of things. Okay, so this is interesting. Many categories available. Safe won't affect the target. Intrusive, they are not safe. Vuln is specifically to scan for vulnerabilities. Sometimes scanning for vulnerability might have some sort of operational security impact for you, the scanner, as well as an operational impact on the victim, right? Sometimes, like, to find out if you're vulnerable to a denial of service, the only way to maybe know that might be to deny service. So exploit, there's a whole category of NSE scripts that actually intentionally violate a service. So that's cool. Auth bypass, so to log into an FTP server anonymously, you can try to brute force credentials. So if you had, credentials in your organization that are expressly banned, for instance, if people aren't allowed to use, the company name as the password, you could scan your network and try to log in with, a couple common variations, their username and, company name 1, company name exclamation point, something like that. Discovery. So the discovery scripts are interesting because you can use those to get really detailed information about services, more in depth. They're saying running a specific SNMP query here. So apparently a lot more of them. So what language are they written in? They're written in Lua, L-U-A. I'm going to submit. Which category of scripts would be a very bad idea to run in production environments? I would say intrusive or exploit. Intrusive. Looks like it's the right number of letters. Yeah, cool. And that's that whole section. Good deal. All right, working with NSE. We looked at the text script. From the vuln category, script equals vuln should come as no surprise to the other categories with the working the same way. So script equals safe. Okay. We use script equals some name of a specific script, or, okay, so here we did whole groups. This one, if we say script equals, I guess, ftp-anon.nse, that is how we would run this specific scan, or this specific script, and no other scripts, just that one. So what else does it say? Multiple scripts can be run simultaneously in this fashion by separating them with a comma. So SMB in num users, SMB in num shares. So for like enumerating users on the computer, as well as the folders that they're sharing. Okay. This can be given with script args. Authenticated. For example, credentials to explain authenticated vulnerability. This can be given. Okay. So let's look at this. HTTP put script args. The put URL is this. The put file is that. Okay. Note that. So they're saying like some scripts, like functions, right? They have arguments to functions or parameters to a function, and this is how you, I guess, provide them. Script -args. Truth be told, I've never intentionally used it. I know that people have. I know that you can. That's not true. I guess we've used that in the past to like brute force some things, where we provide usernames and passwords lists. So yeah, okay. Note that some arguments are separated by commas and connected to the corresponding script with periods. So those are kind of like, I would call them like attributes or fields of, if you kind of want to like keep it in CS land a little bit. So there's a class, and then it has an attribute called URL, and you're assigning it the, this particular string. There's a class called HTTP put, and it has an attribute called file, and it's assigned this particular string. So what optional arguments can the FTP anon NSE take? All right, so we need our terminal back. So I'm going to close or minimize our Visual Studio Code. I'm going to quit nmap, and it says nmap, like, so scripts come with built-in help commands, which can be accessed using this. So I type nmap --script -help, and then the script name. So FTP-anon. All right, so it says categories, default, auth, safe. Checks if an FTP server allows anonymous logins. If anonymous logins allowed, gets the directory listing of the root directory and highlights writable files. What optional arguments does that script take? Ugh, I don't know. Optional arguments. I don't see any. None. It doesn't. That didn't work. FTP anon. What optional arguments can? So I'm going to use Google. Bus detection, FTP-anon.nse. So let's see. Oh, okay. What optional argument can that script take? Max list? I don't know how I would have found that through this. A full list and their corresponding arguments along with example use cases can be found here at the website that we ended up at. So there we go. So it looks like this is the answer, max list, because it's an argument, max list, a maximum number of files to return in the directory listing. Default is 20, MAX-LIST. That was correct. Excellent. Okay, where are we at? Next section. So we know how to use these scripts in Nmap, but we don't know how to find these scripts. Okay. So two options for this. Ideally, be used in conjunction with each other. The first is the page on the Nmap website, which contains a list of all the previous scripts. So I'm going to go back to the index right here. These are all the scripts that exist. There's a ton of them, apparently. Look at that. Specific CVEs I saw in here somewhere, like CVE, Control F, CVE, like, well, I guess there's a bunch of them, but those are all looking really old right now, 20. So let's do CVE hyphen 202, anything? Nah, nothing that modern. 17. Okay, so there's something from like 5 years ago. Is there anything from, or 4 years ago? Is there anything from 3 years ago? Nothing. So that's unfortunate. Apache Strut remote code execution. So they make it really easy to determine whether or not it's, I mean, this was a big deal, the Apache Struts thing. So maybe that's why. Metasploit is a better tool for that, and we'll spend some time looking at that too. Okay. So this is telling us how we can list the stuff in a long listing format in a particular location that match, you know, anything, FTP, anything. So let's copy and paste that command. Let's see what it does. Copy. I see FTP and non, FTP bound, root, libopy, libopi, yeah. Pro FTPD backdoor, syst, vuln 2010, and then TFTP enumeration. So looks like they had all the same stuff that we had. So if we wanted to filter out certain things, what do they do? Script DB. Apparently there's a database of all of them. I can say script.db. I'm sorry, I have to cat it. I can put it onto the screen, and it looks like this lists everything about the Nmap scripting engine, like scripts, and I can filter what I see. Rep safe. I only want to see lines that contain safe. Okay. I only want to see lines that contain, well, it's hard to do. I have to add another pipe. So I want to see safe, absolutely always, but I maybe want to see things that are also vulnerability. So I'm going to grep for vuln. Remember, the last command in the pipeline is responsible for what shows up on the screen. So I shouldn't see anything that isn't at least safe, but all of these should also contain some sort of vulnerability scanning capability. So cool deal. If you want to install new scripts, you have to put them in that location. So which is right here, user share Nmap scripts. And then you can update the script DB to do that. Okay, cool. So search for SMB scripts in the directory using either the demonstrated methods. Which file name is what is the file name of the script that determines underlying OS of an SMB server? So I'm going to look through the script DB because I feel like I like the pipeline method better. Grep SMB. Okay, there's a lot of that. Underlying OS. So I can, that did a lot for me. That kind of broke down SMB server stats, SMB system info, discovery. I guess I need to use both of them. Where was that? I've listed them. I guess I need to like get help, script help. That's what we did. So which one did seem interesting to me? SMB system info. It's asking me to, what is the file name of the script that determines the underlying operating system of the SMB server? Server stats kind of makes sense. System info makes sense. I'm guessing this one because stats, I also think about like performance stats, and that might have to do with like how many connections it had, how long it's been running, how many files it has on it, something like that. Where system info might be more like what version is it running, how, what version is the operating system, so on and so forth. So I'm gonna like maybe some of the policies about it. I'm gonna guess this one. So what did we run earlier? I'm gonna hit Control C, and I typed nmap tag script -help, and then I pasted my command. I used Control Shift V to paste. Okay, so okay, it says pull back the information about the remote system from the registry. Getting all the information requires administrative account, although the user account will still get a lot of it. Probably won't get any, nor will anonymous. Guest won't get any. This goes for all operating systems, including Windows 2000. Does so again, guessing that's it. Let's see. Nope, that wasn't it. What was the other one we were looking at? It was server stats. No, that wasn't it either. Search for SMB scripts in that directory using the, what is the file name of the script that determines the underlying OS? Ah, wait a minute. SMB OS -discovery. There it is. Let's just validate OS. Oops. OS discovery.nse. I think that was it. I think that's it, y'all. SMB OS discovery.nse. Submit. Whoop, whoop. Your answer is correct. Read through the script. What does it depend on? Okay. Read through the script. Are they saying we need to? So where does the script live? It lives in, I'm going to code /user nmap or share nmap scripts. Let's open it up in Visual Studio Code. What does it depend on? Let me zoom out a bit on this. I'm going to look for the word depend. It depends on SMB-brute. SMB-brute. What is another dependency? I don't know. I just guessed on that. I saw dependency and thought, what's the hint say? Look for dependencies equal than the Lua script. Okay. Boop, boop. That's correct. All right, man. So, man, a lot of these might be like good test questions or something. There's a lot of material to talk about, particularly in the networking section. I mean, it's all really the networking section, but like when you're looking at the actual like WireSnark screenshot snippets, there's tons of stuff you have to talk about before you get there. So you could use nmap to build the to generate the traffic, capture it with Wireshark, analyze it, and then test them on this. I guess, I don't know. So which simple and frequently relied upon protocol is often blocked, requiring the use of the PN? Ah, okay. So we've already seen some techniques for bypassing the firewall, the stealth scans. There's another very common firewall configuration, which is imperative we know how to bypass. Your typical Windows host will, with its default firewall, block ICMP, which presents a problem. Not only do we often use ping to manually establish the active target, does the same thing by default. This means, that's, man, what's the first thing I hopped on the thing to do, right? I ping Google. Can I get to Google? If I can get to Google and back, I have internet connection, I'm happy. So this means the nmap will register a host with this firewall configuration as dead. Not only do we need to ping manually, to manually establish the activity of target, nmap does the same thing. So this means that nmap will register a host with this firewall configuration as dead and not bother scanning it at all. So if you don't respond to a ping, I'm going to assume something's wrong. Okay. And I'm not going to bother you anymore. I'm not going to ask you any more questions. Hey, is this port open? Is this port open? So we need to way around that. -pn tells nmap not to bother pinging the host before. Okay, so I think that's the first question. Which and frequently relied upon, and that's ICMP. Which nmap switch allows you to append arbitrary length random data to the end of packets? I think they call that padding, right? So when you're pinging something, you're actually sending, I think depending on the operating system, you're sending like the alphabet, and you can like have it, you're sending the alphabet, and then it will respond to you with that basically. Just again, everything has to be some sort of multiple of 2, right, in computer science. So it allows you to store, some number of extra characters. You can use it to send messages, like little hidden things. So what are we looking for? We're looking for arbitrary length random data. That sounds like more of a Google for me. Nmap random data end of packets. Payload. Okay. We're almost through it, man. We've got this question and then like 2 more things, and then we'll be done with this video. Arbitrary length random data. Data hyphen length. It'll let you include random bytes. Oh, interesting. Okay. To fragment the packets into smaller pieces, scan delay, time base, pad sum, invalid checksum for the packet. Any real TCP IP to drop the packet. However, firewalls may potentially respond automatically without bothering to check checksum of the packet, and as such, this switch presence of firewall. Okay, good deal. Data length, tac DATA hyphen LENGTH. All right. I consulted the internet, and that's what I got. All right, use what you've learned to scan the target machine. So we've got 53 minutes here to get this knocked out. Um, okay, so it says, does this target respond to ICMP? So remember that eons ago when we connected to our VPN and we were online, right? We have this new target. Notice that tryhackme is pretty clever. They can sort of contextually make the question apply to the box that you started earlier when you deployed that machine. I'm going to copy that IP address. I'm going to open a new, or not necessarily a new one, I'll just go back to my console. And this time it looks like we're actually going to, scan a machine. So this one, the question is, does the target 10, 10, 123, 113 respond to ICMP? Well, did we learn that Nmap can do it? Yeah. Let's keep it simple. I'm just going to ping it. Ping that IP address. It does not seem to. Right? I didn't get a response. Normally, if I ping Google or Cloudflare's DNS, I get a response back pretty quickly. So I'm going to say the answer to this is capital N, no. Whoop, whoop, my answer is correct. Perform an XMIS scan on the first 999 ports of the target. How many ports are shown to be open and filtered? An XMIS scan. Okay, well, let's go back up here to XMIS. What is the flag for an XMIS scan? TAC SX. Okay. Back down here in the practical. So the command is TAC, or I'm sorry, it's nmap TAC SX. My target, and it should be the first 999 ports of a target. So I'm going to say TAC P, it should be what, 0-99, 9. Ah, what happened? It says you are requesting a scan type which requires root privileges. I am not running this as an administrator. So remember to sudo password. Get your password correct. There we go. Ah, okay. So what did I not do? Right? It's telling me that the host seems down. I didn't tell it to ignore the fact that it's not responding to ICMP. So I can do TAC, what was it? PN. They're telling me right here, but blocking it. All right. So if it's really up and blocking our ping probes, try TAC PN. So ignore ICMP probe. And it should take a lot longer. You can see it's going about 0.5% a second. Let's come back with some TV magic once this is done. I don't want to make you sit here and watch this. Hacking's terrible, y'all. It takes a long time sometimes. I'm not going to pause. I'm going to make you watch it. There it is. I'll be right back. I'm actually going to go get a drink. No reason not to. Oh, it's back. Good. Hopefully you weren't sitting here very long. All right. Huh. Run an Xmas scan on the first 999 ports of the target. How many are shown to be open or filtered? I think I might have done that wrong. I might like, if I had done 1 to 999, I think it would have scanned only 999 ports instead of 1,000 ports. So it would have said all 999 scan ports on this are open : filtered. And I think given the nature of this question, I'm guessing because the answer is expecting is 3 digits, I'm going to say 999, guessing. And that was a good guess. There's a reason for this. What is it? The answer will be in your scan results. Think carefully about which switch to use and read the hint before asking for help. It's in the, it says that the reason is for this. There's a reason given for this. Undergoing Xmas scan. The answer will be in your scan results. All one. I don't know. What's the hint say? Run this command with the tag. I said we would do that and we didn't do it. So we've got to wait another 200 seconds. Okay. All right. Well, here we go. Let's do it. Computers. All right. So now scanning 999 ports. Okay. I guess I'll be back in like not 200 minutes, but 200 seconds. That's really not that long. So stretch your legs, get up, take a breather. All right. It says it's 45% done. Man, taking a minute. Some of these scans will kind of also be dependent on, I mean, to send a handful of packets doesn't take a long time, like milliseconds, but it's possible that you could like degrade quality of service on your local network. So there's something to be said for that. I know earlier said it's not really a big deal to do it like with an aggressive scan. But if you're in like a place with spotty Wi-Fi, particularly if you're on a Wi-Fi connection in general, and you start sending a lot of traffic, for every instance of communication that you're allowed to have with your laptop, other devices cannot communicate unless they're on like a different channel. From like a physical standpoint, it's kind of like being on a walkie-talkie. Only one person can really talk clearly at a time, unless you're on separate channels. So, yeah. So if you can, scan from a wired connection. It's telling me, all right, so it's unfortunate. So, all right, we don't have to do all of these. Well, yeah, let's just do them sequentially. It'll be easier to do it that way. All right, so it says there's a reason given for this, but how many ports are open or filtered? Because 99, no hyphen responses. Okay, no response. That was the correct answer. All right. Perform a TCP SYN scan on the first 5,000 ports. How many ports are shown to be open? So let's modify our command. We know that we need to leave the PN. We know that's correct, but we don't want an XMIS scan. We want a SYN scan. A big S is a SYN scan. And then we got to go to the first 5,000. 2, 3, 4. And then I'm going to do this T5, get aggressive timing, fast timing. I don't want to take forever. Ah, okay. So now we've got a bunch of stuff. Ports are shown to be open. 1, 2, 3, 4, 5 ports so far. Sweet, man, that was a lot faster. That took 30 seconds to get a response. So there's some timeouts that you can tune in Nmap to make that a little like, so it won't wait 30 seconds. If your computer's not responding to a network communication in 30 seconds, you have bad internet. You know what I mean? A single packet of communication, that's a bad connectivity like issue. I wish they would, I guess, make the defaults less. Sometimes they have timeouts like 15 minutes or something. Craziness. All right. So what's the question here? So perform a SYN scan the first 5,000 ports in the target. How many ports are shown to be open? I see 1, 2, 3, 4, 5. 5 open state ports. Submit. Monitoring result. Make sure you understand what's going on. All right, so let's go ahead and do that for the sake of doing. It's saying open up Wireshark. Let's build our command first. It says perform a TCP connect scan against port 80 on the host. So it's you can still run this as sudo nmap, although it's not required because it's not abusing the protocol. The connect scan I think is the default, but if you're running as root. So I'm going to cite ST for TCP connect against port 80 tech P 80 tech VV, monitoring the results. All right, so that's our host. So as soon as I hit enter, that command is going to run. What I want to do is open up Wireshark. I'm going to also make this window kind of just down here. I'm going to open up Wireshark. Wireshark. It's going to add, it should ask me for my password. My password, there we go. I'm going to put Wireshark up in this top corner. Now, we may or may not have done the Wireshark lab. You may or may not be familiar with Wireshark. what we're doing is we're going to enter or monitor all of the communications on a particular network card. The network card for this virtual computer is the ETH0 network card. Or actually, is that going to work? Interesting. Is that going to work? It should work. No, it won't work. It actually has to go out of, it has to go out of the ton interface. Let's find out. Let's see what happens. Okay. I'm going to fire off the connection. Oh, it worked. Excellent. Sweet. For what does this say? It says we did all of that. Make sure you understand what's going on. Okay. It says nothing needed there. Let's examine this real quick. First things first, in map, it told us what it was going to do. It said, first things first, it's going to try to ping that host. It's going to try to use an ICMP to validate that it can communicate with that host. No response found. And then it's going to, and we know that it's not going to work, right? We didn't get anything from it at all there. What did it say? 80. What happened? There's 80. Okay, hold on. That's, remember, it's not responding to ping. There we go. Okay. I'm going to restart this. Although, I mean, it's interesting to see. It did everything it said it was going to do. It said it if it host is down, it would try to ping. It would send the packet, TCP packet, to 80 and 443, and I see that happening here as well. I'm going to continue without saving. I'm going to restart this whole thing. I see. Okay, so I run it. I see that I have, let's see, did I have ports? Down. Options, TCP, option. Where's my flags? Oh, there they are right there, way up high. Boom, send. So here are the flags. SYN set. All the other flags not set. So this is the SYN. This is the acknowledgement to the SYN. This is my acknowledgement. That's the three-way handshake. And then this is the reset set. So the machine responds to the to my connection request, and then it resets. I'm sorry, my device sends the reset to that computer, and it assumes that, hey, you're good enough. It's good enough to call it a connection. So, boom. Deploy the FTP anon script against the nmap successfully log in. All right. So what was our command? Nmap this. Let's leave 113 as our target. P21. Well, let's just try doing it this way. Let's go tech script. What was the script equals FTP hyphen anon. I think anon, like so. Let's see if that works. I told it not to. I didn't tell it to ignore the ping. So let's try again. In fact, I know that FTP is only running on port 21, so I can make this go a lot faster by saying TAC P21. Okay, so it was doing the scans, it discovered the open port, and now it's starting to run the nmap scripting engine. And what we're looking at here is a bunch of, in Wireshark, you know, the activity that's happening with it, FTP login attempts, apparently. So let's minimize or collapse some of those. FTP request user anonymous. All right, so it says FTP login allowed, cannot get directory listing timeout. Can Nmap successfully log into the FTP server on port 21? Yes. It says anonymous FTP allowed. The port's open, but it cannot get the directory listing. Looks like that was the right answer. I'm going to hit conclusion. It says you've now completed the further Nmap room. Hopefully you enjoyed it and learned something. All right, good deal. I feel like we learned something. It's been a long video. Thanks for hanging in there. Hope that you find this is a valuable resource. I'm going to go ahead and hit completed. And then we get confetti. Yay. All right. And that's the end of the room. When we're done, clean up after yourselves, terminate, stop capturing packets, things like that. All right, well, I'm going to stop the recording. Thanks again.